Assalamualaikum. In this video, let's discuss about the photoelectric effect. But in our previous class, we were discussing about this photoelectric cell. Photoelectric cell. So we know that when light falls on this cathode, we have the emission of electrons. Due to the emission of electron, we get a reading, and we set up this circuit to prove the photoelectric effect using a photoelectric cell. And using that, we obtain a graph. So the graph uh, I versus the external voltage V. So initially, when the applied voltage is zero, there was a photocurrent. And when the applied voltage was increased, the photocurrent increased, and after that it remained constant. We discussed the reason why. Then we reversed the terminals and conducted the same experiment to find out something interesting happens behind. So we got a situation where the current becomes zero, and we call that voltage as the stopping voltage Vs. We also went through the reason why we have a stopping voltage. And then we also discussed about this equation where the energy of a photon when it is absorbed by an electron to get emitted when it is absorbed by a surface and the electron is emitted or ejected, the work function for this material is always a constant. So depending on the photon, the work function is constant for that material. Depending on the photon, only the kinetic energy maximum is going to change. Then, when we shine a light with photons of energy E1 and we shine light or electromagnetic radiation with photons of energy 2, where the energy 2 is greater than energy 1, in that case, we can tell that electrons ejected due to these photons will have less kinetic energy. Kinetic energy 1 is less than kinetic energy 2. Reason: same amount of energy from E1 is used for work function and same amount of energy from E2 will be used for work function. Whatever remaining becomes the kinetic energy. Now let's go through these notes. When the intensity of radiation is increased, photocurrent increases since the number of emission proportional to intensity. What do we mean by increasing the intensity of radiation? If I increase the intensity of radiation, number of photons is increased. We know that one photon only will remove a single electron. If the number of photons increase, obviously the number of electrons removed is going to increase. If number of electrons removed is increased, photocurrent increases. But does it make a change to the stopping voltage? Let's look at it. We know that stopping voltage depends on the kinetic energy maximum of electrons. Here we have the same light. Here and here we use the same light. Therefore, the energy of a single photon E is equal work function plus kinetic energy maximum. E is the same for this case and this case. E is the same. Work function is also the same because it's the same material. Therefore, kinetic energy maximum is the same. If kinetic energy maximum remains the same, stopping voltage will be the same for both the cases. Then, when we increase the intensity, only the photocurrent increases. But Vs stopping voltage is the same. Let's include that point too. Now let's look at graph for different frequency but same intensity. What do we mean by same intensity? That means the number of photons is same. If number of photons is same between these two instances, that means number of ejected electron is also the same, which in turn is the current, right? Therefore, the current doesn't change. But what might happen to the stopping voltage? Let's look at it. We know the energy of a photon is used for the work function and remaining is given for the kinetic energy. So here we have considered F1 is greater than F2, frequency 1 is greater than frequency 2. That means energy 1 is greater than energy 2. We're talking about the photon energy. Anyways, it's the same material, therefore the work function is same. Whoever has more photon energy will have more kinetic energy, which in turn will have more stopping voltage. Vs also increases. So E1 has more energy. That means kinetic energy 1 is greater than kinetic energy 2. And it also provides the idea that Vs dash or Vs dash is greater than Vs. So this is frequency F1 and this is frequency F2. Let's include these two, F1 and F2. Note number 3, I'll skip. There is a small confusion in that. I'll check and let you know, okay? Next, let us look at the expression for photoelectric emission by Einstein. So, according to Einstein, the energy of a photon is work function plus kinetic energy maximum. We already discussed this equation, but there we didn't state whose idea was that. So now we know whose idea is this E is equal phi plus kinetic energy maximum. Then we have the Planck's equation. E is equal hf. E is equal hf, and work function we know it is h times the threshold frequency, and then kinetic energy maximum is the same. So let's subject kinetic energy maximum, then we get an equation in the form y is equal mx minus c. So here the graph we only draw up to f naught. The reason is below f naught, we do not have this photoelectric emission. The photoelectric emission happens only beyond F naught. Now let's look at a few materials: cesium, calcium, and sodium. In these materials, it's easy for us to remove an electron from cesium than from potassium than from sodium. So work function of cesium is the least than calcium or potassium. If we draw the graph, all of them have the same gradient. Similarly, we can get an equation for stopping voltage versus frequency. Here also we have the same threshold frequency. The fourth note, again we have considered all the uh, three different materials and drawn the graph. In all of these cases, this gradient is the same. So that's all about this section. Assalamu alaikum.